Hi. So we are gonna be fleshing out the rest of the enemy stats for today, and that will be for part 22, and then that will prepare us for the next part, which is to create a buff and debuff system for the enemies and the player. So I realized that if we do not have a buff and debuff system, then there are some weapons that we just can't create. So for example, like there is this freezing weapon in Vampire Survivors. It's called something Lancet, I think. And we can't create that because there's no buffs and debuffs. And we also cannot implement the knockback that the garlic has. So if you hit an enemy with the garlic, for example, their knockback multiplier is increased, but you can't do that as well. So today we're gonna implement that, and then in the next part we're gonna implement buffs and debuffs so that you can actually see that in action, and that will give us a very robust enemy system and a weapon system. So let's get started. Okay, so just to provide some context as to what I'm talking about. If you look at our enemies after we finish part 20, right, the enemy spawning system is fantastic. You know, you get a bunch of mobs and you get different spawns and stuff, which I'm very happy about. And I've also added I've created a new video. We've released a new video last week as well, talking about how to add sound effects to your weapons. So now we have sounds in our project files, and we have enemies and stuff. And we also, after 30 seconds, I think, we get mobs that spawn. So we've created a mob that basically is a swarm of enemies, and then we've created also flower walls. See the swarm of enemies here. So we've created a bunch of mobs, and you know, you have different mobs that spawn and everything, which is pretty cool. So in terms of the enemy spawning system, you know, we've got something very nice going on here. So if you look at our enemy prefabs, right, the enemy stats, well, they're not set up in a very ideal way because we just have current move speed, current health, current damage. So in the last part, we removed the enemy's dependency on enemy scriptable objects, right? Because anyway, these enemies are prefabbed, so we can already store the stats. But by just storing the stats in this way, it makes it very difficult for us to apply buffs and debuffs. We also haven't implemented all of the stats that the enemies have. So if you look at the Vampire Survivors wiki, you will see that enemies have a couple of stats. They have a health, they have power, power is just damage. And they have speed, they have knockback stat, which controls how much knockback they receive. And they also have an experience stat, which, well, the experience stat, we've already implemented it in the drop rate manager. But so we don't have to implement the experience stat, but we do have to implement the knockback stat. And then we also have a bunch of resistances like this. We have freeze, we have kill resistance, we have debuff resistance. And we have a couple of things as well, like we have a HP boost, and then we have curse as well. Okay, so the fixed direction and the floaty, we are implementing it by changing the enemy movement script. But then there are still some stats that we want to implement. And the other thing that we want to do as well is, if you look at the player character, recall that we have a base stats and the actual stats. And the actual stats, well, it's not supposed to be adjusted by us, so this technically should be hidden. So if you make this private, it'll be a good thing. I just made it public when I was creating the player stats because I wanted a way for us to check to see, you know, what the player's actual stats was. But well, you can make this private, it's fine. So why do we have two stats? Why do we create two stats for the player character? It's because the base stats are there so that we can calculate the actual stats. And for the player character, right, why do we need two stats? Well, the player stats are boosted by passives, right? So if you get passive items, you will boost the stats. So for example, let's say you get armor, this will boost your armor stat. If you get a clover, this will boost your luck stat, and so on. So because there is a need for us to record stat boosts, we record a set of base stats so that we always know what values to revert to. So let's say if we remove the passives, then the stats will revert back to the base stats, right? So if you recall in player stats, all the way back in part 15, right? Player stats script, we've created a new function called calculate stats. And this is what helps us to recalculate the stats every time we receive a new passive item. See that? This allows us to not just add passive items, because when you add passive items, you add stats, right? But because you have recorded the base stats, right? Whenever you remove the passive item, this will allow us to revert back to the original set of stats. So let's say if I have 5 passives, then this will take into account all 5 passives, and from there it will calculate the actual stats of the player. So now in the next frame, if I remove, let's say 2 passives, then this script, if we call this script, it will take the base stats again, but it will only take the 3 remaining passives as into account and then calculate the stats for us. So then by recording the base stats, we have a system that allows us to track whatever stats that we have, and this builds into the buff and debuff system as well, because like passives, right, buffs and debuffs are meant to be added, right? So for that reason, our current enemy setup cannot work because they do not store two sets of stats, they only store a single set, and it's not all grouped together, which makes it a little hard to manage. So what I'm gonna do is, for the enemies, I'm gonna set up a structure that is similar to the player like this, where you have the base stats and the actual stats, and then once that's done, this will allow us a lot more room to implement modifiers like curves, or modifiers like some enemies, their HP increases as you level up. It's called HP times level in the Vampire Survivors wiki. So then this allows us to implement stuff like this. So I've explained why we want to reorganize the enemy stats script, right? It's so that it makes the whole thing easy to manage. So what we want to do instead is to build something like this, where you have the base stats and then you have the actual stats. And then notice that there are a couple more stats that are inside there. So we're gonna build something similar in the enemy stats, which means that we will have to go to the enemy stats script and add a bunch of new structs. So we want to go to the enemy stats here and then just add two new structs over here. So we have a struct for resistances, and then we have a struct for stats. And what we want to do is to build a new stats object here, like two objects, one base stats and then one actual stats. This will give us the new component. Okay, I will go through what these new components do in a while. So let me just show you how the new component looks like first. So when we grab the new enemy stats script over here, we will also have to make a couple of changes to our codes, because previously our move speed stat was given by current move speed, right? But then now it's changed. Okay, so in the code that I've just shown you just now, what we have here is we have base stats, we have actual stats, and these are based on the stats struct that we have. And I've also created, this is what is called a getter, and this basically gives us the actual stats. Because the actual stats itself, the value here is private, so then we are not able to access it from other scripts. So then this actual getter allows us to access the actual stats. So what this allows us to do is, it doesn't allow the other scripts to modify the actual stats, but it allows it to only retrieve the value of the actual stats. And let me just update the movement scripts first, and I'm going to show you what's changed about the enemy stats script. So if you grab the script from us, you will also have to go back to your enemy movement script and then make sure that you change this to actual. So now it's enemy.actual.movespeed, and you want to update this in your enemy movement script as well as the charging enemy movement script. So this again becomes enemy.actual.movespeed. What I also like to do, right, is, well, in the enemy movement, I've renamed one of the variables here, and that variable that I renamed is this enemy stats. So I prefer to call it stats because we are already in enemy movement, right? So that tells us that we are really dealing with something that the enemy has. Stats tells you more about the enemy you are modifying. So it's up to you if you want to change this. I just thought that, you know, changing this just makes a little bit more sense. And if you remember, if you checked out our previous part, I talked about self-documentation, right? How you want to make every script that you have as self-documenting as possible. What this means is that your scripts, when I take a look at the script, either the script itself or the component, the naming of the variables and functions should tell you about what the script does. That is the ideal, which is why I'm so particular about the names. So what I've done here is I've just changed the reference to the move speed because it's now retrieved in a different way. Now the move speed is packed inside a data structure, so then we will need to retrieve the value from the data structure itself. And these changes allow us to see the new enemy stats, which I think are pretty cool. So now you have resistances that you can set, and then you have, of course, different health stats, and speed stats, and we also have an extra knockback multiplier stat. So then this allows us, of course, to go to the flower wall, and the flower is hard knockback, right, in the game, so you can reduce the knockback multiplier, and this will slow the amount of pushback that the flower receives. Okay, so let me run through the code, the changes to the enemy stats script. So we're creating two new data structures, the resistances data structure and the stats data structure. This allows us to create two variables that are stats, and we have base stats here and then actual stats here. And then this, of course, allows us to set up a structure like this. So when you create the base stats and you go back to Unity, you will see the base stats object is dropped down like this, that has all these different stats. And if you want to delve it even deeper, you can actually click on this here and then go to debug. And this will actually show you not just the base stats, but the actual stats. The reason why the actual stats is hidden and private is because the actual stats are calculated in the game. So when you are setting the values for the enemies, the actual stats itself doesn't have to have values, that's why it's hidden. So the actual stats value is only valuable for us when we are debugging the stats system that we have. And in the next part, if we are doing the buff and debuff system, to check if the buffs and debuffs actually work, we will have to check out the actual stats of the enemy, not the base stats. And so once we create these structures, we create a getter called actual so that we can retrieve the actual stats. This is for the other scripts that refer to the values that are inside enemy stats. For example, our enemy movement script, which we have just modified. Because we need to retrieve the move speed from the actual stats, we will have to create a getter like this that gives us the actual stats, because otherwise the actual stats object is private and we can't access it from other scripts. We keep the current health, or rather we create a new current health variable as well that replaces the old current health stat. So the current health is important because we only get to set max health. The current health will always be equals to the max health. And we remove a couple of variables. One of the variables we remove besides the old stats is the player variable because it's not used. So I don't know why it was there, but because it was not used, I removed it as well. And yeah, so then we remove the line that sets the player as well again because it is not used. And we call this function called recalculate stats, very similar to the player stats function called recalculate stats, and then we also set the current health to the max health. So then recalculate stats for now just sets the actual stats to the base stats, but later on in the parts, in this part, we're also going to add some formulas inside here, because don't forget that we have the curse effect. So then we're going to take into account the curse effect to modify the actual stats of the enemy based on the base stats, of course. And that's really all the changes. Okay, we also did a small optimization on the collision stay 2D function. The reason why we did it is because previously, right, when there is a collision with our enemy, we will check whether the other object that we are colliding with is tagged player, and then if it is, then we will find the player stats component and deal damage to the player. But well, there's actually a much shorter way to do it that doesn't involve tags. Personally, I don't like to use tags because tags add a lot of work. So for example, if you need your tags to work, you have to always remember to add the player tag to all your player characters. If you use tags a lot to identify different enemies, then it's just gonna make the entire management of your different prefabs or game objects, it's gonna make it very complicated. So instead of using tags, what I like to do is I like to just check for a component. So I like to just check for, over here I'm using try-get component. This checks if the colliding object has a player stats component. If it has, then right away this value p, because over here this is called an out variable. What this means is that if you put this value here, then this function, if it finds a player stats object, is gonna assign it to p, and then this p can be used to deal damage to the player. So this makes our code a lot shorter, which is why I prefer to use this structure instead of using this structure. And this also has the added benefit of not needing us to use tags to identify the player character. Oh yeah, one more thing I forgot to mention actually is that when we updated the take damage, okay, so previously we used the current damage value, and now we are changing this to actual damage, because again, we are changing the way that the stats are stored. So then the variables that refer to our different stats have to change. So that about wraps it up for the changes to the enemy stats object. And once we are done, right, once we have all these stats over here, you want to spend some time to go to all your prefabs and make sure that you set the stats values accordingly, because of the change in the data structures, right, you're gonna lose your stats that you've previously set based on the old system. So you have to just run through all your prefabs and then reset all the stats. It's very important. Okay, otherwise your enemies won't have health. They're not gonna be able to move very well as well. So it's not the best thing. So now that we are done here, let's look at the next part. So once we are done here, let's implement our stats, because there are a couple of stats that are unimplemented. So we have the knockback multiplier here, which is unimplemented. We also have the freeze stat and the debuff stat, which is unimplemented. The problem with this is that we don't have a freeze effect and we don't have a debuff effect as well, because we need a buff and debuff system for that, right? So we only have a way to implement the kill resistance. So we're going to implement a knockback multiplier, the knockback resistance first, and then we're going to implement the kill resistance. And then after that, we will do a couple of things to circumvent some scenarios that you might have found in part 21 of our series. Okay, so let's look at our knockback stat again. So technically, well, if we want to keep things simple, right, it's just we have to multiply the knockback by the knockback multiplier here, and this will actually fix, or rather implement, the knockback multiplier stat into our game. But you know, because we are building this tutorial, right, so that most of you who are watching here, if you followed this far, you probably want to build your own game, right? So what we're gonna do is add a little more complexity movement component. So I want you to be able to customize the way that your enemies are knocked back as well. So when you knock an enemy back, notice that you're able to set both the velocity and the duration of the knockback. So what I'm gonna do here is to multiply. I want to be able to multiply both the velocity and the duration of the multiplier. The problem is that if I multiply this twice, then you're gonna get 4 times the effect. When you, so for example, if I do a knockback multiplier 1.5, instead of getting a knockback multiplier 1.5, you're gonna get a knockback multiplier of 2.25, because 1.5 times 1.5, right? Because you are multiplying this value twice, you're increasing the velocity and the duration. But this is a problem that we'll tackle later. Okay, so in the code that I will be showing you later, we are also introducing a new variable here called knockback variance that allows you to set whether the knockback multiplier will affect the velocity, the duration, or both. Or if you don't want your enemy to be knocked back at all, you can just set the knockback variance to nothing, and this will make the enemy immune to knockbacks. So then you have a couple of options here with how you want your enemies to be knocked back. For some enemies, you may want to shorten the knockback duration only. For some enemies, you may want to shorten the knockback force, the velocity. And for some enemies, you may want to shorten both. So if we want the enemies to be knocked back by both the velocity and the duration, we will also have to reduce the amount of the knockback that we are getting. So let me just explain to you what I mean. So the amount of knockback that you get, right? Let's say we have a bad guy over here, okay, and then we have a knockback effect on it. So how far the bad guy travels after getting knocked back is based on 2 things. The first thing is the velocity, or the force knockback. That's the first factor that will affect how far it travels. Second is the duration of knockback. So because of these 2 things, if you adjust either of these 2 things, you will affect the distance of the knockback, because the distance that you're knocked back essentially is determined by velocity times duration, right? So when you want to reduce the knockback, you can either reduce the velocity, or you can reduce the duration, or you can reduce both. So if our multiplier is 0.5, right? So let's say the knockback multiplier here is 0.5. Then what this means is that I want to halve the distance that the player travels. So if the knockback used to be, let's say, this arrow's distance, I want to reduce the knockback's distance to this. For me to be able to reduce this, I only have to multiply the multiplier by either one of these values. So I want to put a multiplier of 0.5 either to velocity or to knockback. If I put it onto both, right, what I'll get is I will get double the effect. So if I multiply both by 0.5, then basically I'll get a 25% reduction instead of a 50% reduction, because 0.5 times 0.5 is 0.25, right? So if I'm halving both the velocity and the duration, then my final travel distance will be 25% of the original value, and that is not what I want, because then what is the point of the knockback multiplier if it's not accurate, right? I want it to be accurate. So this means that if I want to have a knockback multiplier of 0.5, but I also want to affect both the velocity and the duration of the knockback, I will have to do something. Okay, so let's talk about some basic math over here. So I want, when I multiply both values, I want to find a value where if I multiply this value to both the velocity and the duration, this will give me exactly half. of the distance. And the way I get this is by using square root. So if I do a square root of 0.5, then well, this value is about 0.707, and this value here, right, if I multiply it to both here and here, then I will get a distance reduction of 0.5. Why is that the case? Because, well, again, it's basic math. So if I take the square root of 0.5 and I multiply it by the square root of 0.5, this will actually give me 0.5, right? So this is why when I multiply the square root by to both the velocity and the duration, this gives me back 0.5, and then this reduces the travel distance by exactly 50%. It's a little bit of math, so you just have to be able to play around with figures and have a basic understanding of how algebra works to work this out. But if you don't understand this, it's fine, as long as you understand the idea behind us having to reduce the knockback multiplier. That's important, because otherwise we are not going to get a multiplier that reflects the actual knockback that the enemies receive. I mean, if you see something on the screen that doesn't reflect the values that you put in, well, obviously it's a bug, right? And you don't want to have bugs in your system. So that is what I'm doing here. I'm creating a way for you to control what kind of knockback you want to have, and then also doing some math to make sure that no matter what option you select, you will always get the same knockback amount that you set your knockback multiplier to. So we're gonna grab the enemy movement script. And then I'm just gonna run through with you what's going on over here. So knockback variance over here is an enumeration. It's also a flag, which gives us the option of selecting any one of these options. Okay, so we only have velocity and duration inside the flags here, and then we also have nothing. Okay, if you don't want either velocity or duration, you can select multiple options over here. We have a rigid body. I'll explain why later. We added a rigid body, and this knockback variance here is used to create a new variable, and the default value is velocity, meaning that by default, if you knock back an enemy, it's just gonna slow the velocity but keep the duration of the knockback. And we assign the rigid body component over here. This is because we are going to use it later. In the knockback function, this is where the main changes occur. So instead of setting knockback velocity and duration just to the velocity and duration that we have here, this is covered in part 14. How knockback is implemented is covered in part 14. So here we're just expanding on the feature a little bit. And what I'm doing here then is that I'm setting this power to 1. The reason why I'm setting power to 1 is because we are using square root. And square root, essentially, if I want to take a square root of a number x, a square root of a number x is equivalent to x to the power of half. That is why we are doing this, because, well, if you are working with code, there oftentimes you have a square root function, but you're not going to have a cube root function, or if you want to root to the 4 to the power of 5 and all that stuff, you're not going to have that. So whenever you want to do, for example, operations like x, and you want to root to the power of 4, then you would do x, and this would be 1 over 4. This is why the variable here is called power. So power of 1 means just, well, it's just the same value. But here we are checking if our flags here, it reduces velocity or it reduces duration. This is called a bitwise operator, and, well, I guess I have to cover what a bitwise operator is as well, right? So this, if you recall this knockback variance, the type is actually a flag. And what a flag is essentially, well, a flag is just, it's a bunch of booleans. So if I have, for example, if you look at the layers in Unity, these are all flags. Okay, flags allow us to, at times, assign multiple values to one single option. So if you go back to, say, our item data, for example, okay, and you go to evolution data, you are able to select, you know, multiple values over here. These are called flags, and flags basically operate by using, well, flags, because flags are essentially just a bunch of zeros and ones, and you can think of them as a bunch of booleans as well. What are booleans? Booleans are true or false values. So you can think of them as having the flags are basically a series of 32 zeros, and you can set any one of them to 1. and they are used for different purposes. They're very efficient for storing booleans because you take 4 bytes space and you can store 32 of them, as opposed to if you store regular boolean. These are booleans, all right, true and false values. So if you use a single variable for a boolean, then it's quite a waste of space because you have 1 byte for the boolean. But then if you are storing the booleans in the flag, then you have, well, you have 1 byte here, so this is total of 4 bytes. For 4 bytes, you can store 32 booleans. And what we are doing here is in our flags here, we only have 2 possible values, which means that our flag here only has these possible combinations: 0, 0, 0, 1, 1, 0, or 1, 1, which corresponds, right? Because what we have here is that we are able to actually only select either duration, velocity, or both, or neither. So then we have these 4 possible values. The nothing and everything are just shortcuts that Unity adds for us, but the real values are duration and velocity over here. My code over here is called bitwise AND operation. What this is basically if I have a set of flags over here. So for example, I want to enable velocity and want to disable duration. So then if I want to check whether velocity is enabled, I will check like this. And what this bitwise AND is basically, bitwise AND means that if both values are 1, then I'll get a 1. So the solution to this operation here, this is called a bitwise AND operation, is as follows. This, because over here the 2 values here are 1, so then this gives me a 1. Whereas if I have, let's say if my flags are set like that, then this will give me 1 and 0, which will give me 0, because 1 and 0 gives 0, 0 and 1 also gives 0, so this will give me 0. So then I want to check if these two, this column of numbers here, if both of them are 1s, because if both of them are 1s, then this gives me a 1, and then this will give me a value that is greater than 0. So why do we have a greater than 0 check over here? The reason is because this whole thing is actually a number, alright? Because if you have numbers in code, the code is usually stored in binary. So these 32 flags over here, right? Every possible configuration of the flags over here corresponds to a certain number. So for example, if my flags are 1 on the last 2 values, then this is actually a value of 0, 1, 2, 3. So this is actually a value of 3. Alright, again, this has to do with binary counting. So how computers count is 0 is 0, 1 is 1, 2 is that, and then 3 is like this, and then 4 is, and then 5 is 101, and 6 is 110, and so on. So then what we have here is these flags also correspond to a number, so every number will actually give us a specific combination of our flags. So then if we do an AND operation, because whenever we check for one single value here, right, the single value is always going to be something like this. So it's either it's all zeros and there's a 1 somewhere. Okay, so this 1 is just in like a different place every time, and then to check different flags. And then once we get 2 1s, then we will get a 1 here. So because of that, if we do a bitwise AND operation and we get a value that's more than 0, then we can be sure that the flag is. So then we are here checking whether the velocity flag is turned on, and for the other one we are checking the duration flag is turned on. Then we are converting these to booleans so that we can check if reduces velocity and reduces duration is on. So once I check the values of whether velocity and duration are activated. Okay, so here if we are both reducing velocity and duration, then we will want to get this to the power of 0.5 because we are multiplying both the velocity and the duration with the knockback multiplier. Yeah, so then this power, if it's 1, if this value remains 1, this means that only one of these is activated, and if only one of these is activated, then this power here will be 1, so the multiplier will be 1. And the other thing that I want to bring your attention to is that we have this little thing called a ternary operator here as well. What this ternary operator does is that only if reduces velocity is active, then you will get the value here, and then you will set this to the power here, and then otherwise you will get the value to be 1. So if the value is 1, means velocity times 1, which keeps the velocity the same. And if reduction is not active, same thing, duration times 1 will give you back duration. Okay, so if velocity is reduced, then of course you will take the knockback multiplier and raise it to the power of whatever we set. Again, because it's only 1 or 0.5, you will get either 1 here, which is the same value, or you will get 0.5 here, which is, well, a reduced value. So with that, I've explained everything that there is to explain in the knockback function. Okay, again, this is made a little bit more complicated just to give you more control over the options that you have. So now if you go over to your enemies, you realize that you will have a lot more control over the kind of knockback that you want your enemies to have under the enemy movement. So you can have knockback variance here, and then you can control whether it's velocity, duration, or both. Or you can have no knockback at all, which means that this enemy becomes immune to knockback. So if I have a knockback multiplier of, let's say, 0.1, let me set this to 0.1, then the knockback variance here, let's say, is just velocity. What this does is that it makes the flower extremely hard to knock back, and well, it only knocks back 10% of the usual distance. And you see the knockback is really very little, just because the velocity is reduced. Okay, I'm going to show you another example but with duration now. So if I set a knockback to duration, you will see that now the knockback effect, it just happens over a way shorter amount of time, but the speed is the same. See that? So now you see the knockback is a lot less. It's just a very short time that it happens over. So these are two ways that you can modify knockback, and you can see also if I try to have a knockback variance of everything, which is duration and velocity, you will see again this whole thing will behave in a different manner. You will see a little bit of the duration reduced and a little bit of the knockback force reduced as well. Okay, so you can see a visible change. And one thing that we have to fix later is notice that the flower here is getting pushed by the bats. So we have to deal with that later. But after making all these changes, you being able to control how much knockback an enemy has gives you a lot more leeway to play around with in terms of how you can tune your enemies to be either more difficult to kill or more easy to kill and avoid. And the last thing that we are modifying in the enemy movement script is actually the move function. So here in the move function, previously we only had one way of moving the enemy, and that is that we are adjusting the position directly. This is not the best thing to do, because if you have a rigid body on your enemy, it's always better to use rigid body move position to move the enemy around, because if you move the enemy, the rigid body doesn't update, so then there may be some collision glitches that may happen. So wherever you have a rigid body, it's always best to move the enemy's position using rb.move position as opposed to using transform.position. This is the only change that I've made, and there's a comment here that explains why this change is made as well. And this is the reason why we added a rigid body. Well, it's not to control the rigid body, it's to check if there is a rigid body. Because in the start function, right, if we run this piece of code and then there is no rigid body on the enemy, then this will just give you an empty object, because this will be empty. And then when you get to the move function over here, this will fail because there is no rigid body, and then we will just try and move the position of the object. So only if a rigid body exists, then we will try to move the rigid body instead of moving the position directly. It's minor optimization to the game, but it's a good thing, because Unity always tells you, if you read the documentation, it always tells you whenever you have a rigid body, you want to do a move position instead of a transform position. So now that we have implemented knockback, the updates to the move function are explained over here, and you can also test out the knockback multiplier. If you apply it to the flower, as if you've played the game before, you will find that the flower is very hard to push away, right? So with the new knockback multiplier feature, you will find that you can implement the same features into your enemies as well, okay, to your flowers as well. And once that is done, you will find that next thing you want to do is to fix collision jankiness. What do I mean by that? Okay, so just now you saw that the flowers, we can push the flower around, right? The bat can push the flower around. You've seen this a couple of times just now. So that is something that you want to fix. And the other thing that you want to fix as well is you will find that enemies are blocked by the environment like this. So for example, here I have a swarm of bats flying, and then you will see this square block, and then the square block is just straight up blocking some of the bats, and they're just not being able to move. And the other thing as well is that you will find this pretty funny situation where you have a flower wall and the flower wall is there, right, and they're blocking the bats. So the mobs are just trying to rush through, but because the space is too small, not all of them are able to get through. So we wanna implement a couple of changes to our mobs so that these kinds of situations doesn't happen. The easiest way to do this is actually to make my mobs kinematic, which means that I just have to go to my mobs over here and just change the rigid body from dynamic to kinematic. What kinematic does, we have an article that explains all of this. What kinematic does is that basically it makes a rigid body not be affected by collisions. It can push things, but it cannot be pushed. Let me repeat this again, alright? So if I make something a kinematic, this means that the body can push other objects, but it cannot be pushed by itself. So for example, the flying enemies, right? You want the flying enemies to not have their collisions be impeded by environmental objects. So then what a kinematic rigid body is that if a rigid body is kinematic, it's not gonna consider other objects in its way. It's just gonna fly through collisions, and anything that is in its way that is not kinematic will be affected by it. So then if you have an environmental object, because the environmental object is immovable, and then the bats, because they're kinematic, now their movement cannot be stopped. You will see the bats will just fly through the boxes. So we want to change the mobs to be kinematic, And we also, if you don't want the flower wall enemy to block other enemies, you can also make the flower wall enemy kinematic. If you make the flower wall enemy kinematic, this will allow other enemies to pass through the flower wall, but it will not allow the player to pass through. This is because the player is a rigid body that is dynamic. So kinematic objects only block dynamic objects. They do not block other kinematic objects. So by having the flower wall be a by having the flower wall be a kinematic, this will prevent other enemies from pushing it around also. So right now I'm just gonna change the flower to a kinematic object, and then let me just put a flower onto the seed. You'll realize that the flower wall can no longer be pushed. See that? It will just ignore the enemy. So it still blocks the player, it just doesn't block other enemies. And you will see the bat mob has the same thing now. So if I put a bat here, it's just gonna be able to fly through the environment. Yeah, see that? Just because it is now a kinematic. So kinematic objects are pretty cool, and by setting certain of your game objects to kinematic strategically, right, this will allow you to circumvent a lot of the junkiness that you will find, like for example the flower wall getting pushed, or the flower wall, or the bats being blocked by the flower wall, or the bats being blocked by the environment objects. So think about what objects you want to set to kinematic. Basically, when something is kinematic, they are not affected by collision. They will just fly through everything, or everything that is hitting them will ignore them. So this is pretty cool. So what I've done is I've made the bats all kinematic, because then they act like flying objects, they can fly over everything, and the flower wall is just done this way so that it cannot be pushed. Okay, so this is the first method you can think about if you want to fix jankiness or janky movement characteristics in enemies. Second thing that you can consider is that you can look at the colliders of all your enemies and environment objects, and you can change the colliders from a square to a circle. The reason for this is as follows. Alright, so for example, my zombie mob, I still want my zombies to be affected by collision, because it doesn't make sense for them to ignore colliding with everything, because they're on the ground. For the bats, it makes sense for them because, well, bats they fly, right? So it makes sense if they fly over something. But for the zombie, I'm not gonna change the zombie to a kinematic. This is because I want the zombie to be blocked by objects. I don't want the zombie to be able to just fly over objects. So then for other situations where you have the environment objects blocking the, let's say, your zombies, you are still gonna get some issues if you have a mob of them and they're all stuck behind, let's say, a plant or a rock. And how you can fix this is by looking at all your game objects and making sure that their colliders are circular. Because if their colliders are circular, it's much harder to clip on them. Okay, so just now I showed you an example of a zombie getting stuck on a square collider object. So right now, if I were to go to my rock here, right, and let's say if I change the rock, the collider, let me change this collider from a box collider to a circle collider. So now I have a circle collider, right? I'm gonna just move my character under the rock, and I'm gonna put a zombie above the circle collider. You will find that the zombie has an easier way finding its way around the circle collider, just because the circle doesn't block you in the right angle. So let me show this to you. See that the zombie has an easier time going around, as opposed to if we have a square collider. If we have a square collider, it's gonna be harder for the zombie to find its way around. So you want to make sure that all your objects are changed to a circle collider like this. Then this will make collision much easier to handle, much less clipping. The third thing that you can consider is you can go to the layer collision matrix, and then you can just think about what layers you want to assign your enemies to. So for example, you may want to have flying enemies and grounded enemies, and you may want to set the collision layer matrix to be as follows. So let's say flying enemies do not collide with grounded enemies, and flying enemies do not collide with flying enemies. Though you want to make sure that you do not disable the collision with the default layer, because that is where our player is in. So if you disable the collision with default layer, then what's going to happen is that you will find that your players will not be damaged by enemies while flying as well. So you want to be extremely careful with using the collision matrix. If you want to find that, it's inside Edit, Project Settings, and under Physics 2, you will find all the checkboxes here. And the more layers you add, the more checkboxes you will have. And this is just a pretty cool and pretty easy way to control which layers, which category of objects collide with one another and which categories don't. Personally, I don't use the collision layer, the layer matrix, because I find that just being able to set something in kinematic for the most part is enough for me. So in future, we may have to use this, but for now, I am not using this. But if you want to use this, just be my guest. It's a pretty powerful way to control behaviors in a very specific way. So we have a couple more things we want to implement. We want to implement kill resistance and want to implement cuts. Okay, kill resistance is pretty easy to implement. Okay, it's just a very small change inside the enemy stat script. And all you want to do is just go to take damage function over here, and we want to be very specific with the way that we implement the kill resistance. And the reason for that is because we don't want everything to trigger kill resistance. So let's say if I have very weak enemies, let's say we have the bat, and the bat has like 5 health, and then you have a whip that does maybe 7 damage. If you have a scenario like this where you have a weapon that deals more damage than your enemies, then every enemy when they get hit is gonna trigger kill resistance. So the modification is inside the take damage function, and you'll see take damage. What the function does is it just deals damage, and it basically checks whether you need to do a floating text and then apply knockback. So all the things that happen when an enemy takes damage is baked into the take damage function, right? So kill resistance, right, it's gonna be over here as well. And what triggers kill resistance is, if you look at Vampire Survivor, some weapons that will deal exactly the amount of damage that the enemy has in health. So for example, if the enemy's health is 5 and let's say the pentagram, if the pentagram activates, then it's gonna kill the enemies that are around, right? When an instant kill weapon triggers, it's just gonna deal damage equals to the max health of the enemy. So here when we have take damage, we check whether the damage is equals exactly to the max health of the enemy. If it is, then we will ignore the damage. This is if we have enough kill resistance. Okay, so how does the logic of this works is, we have this random dot value over here, and this will give us a value between 0 to 1. And then we also have an actual stats, kill resistance. So if you recall, kill resistance is a value also from 0 to 1. So if the kill resistance here is, let's say, 0.5, you will see that you have about 50% chance to survive instant kill attacks, and if your kill resistance is 1, you'll always survive instant kill attacks. So then this random value here gives us a value between 0 to 1 as well. So if my kill resistance is, let's say, 0.1, this means that I have a 10% chance of getting a number below 0.1, which means I have a 10% chance of surviving. And this is how this is done. So again, take note, you only want to have the kill resistance do a check of whether you should survive the attack if the damage is equals exactly to the maximum health. If it's not, then you will want to ignore this effect. And the reason for this is because otherwise you will have a lot of weapons triggering this, because there are a lot of weapons that do more damage than the enemy's health. And so kill resistance is pretty simple to implement. Yeah, it's just a little chunk of code inside take damage that you have to implement, and that fixes the issue. Okay, and then the rest of the code is just the same. So let me just grab this piece of code and put it into the project. And the next thing we want to do also is to implement two things, the curse boost and the level boost. And this is where things get pretty interesting. So before we start doing this, right, I'm gonna do a thing where I maintain parity with the player stats. What do I mean by that? So player stats actually has a stats variable that gives us the value of the actual stats. And what I'm gonna do is to add one more variable here called actual. And what this does for us is that this allows us to, because if you look at the enemy stats object, you use stats.actual to retrieve the value. And as far as possible, you want the conventions, the coding conventions, to be the same across scripts, because otherwise it gets confusing. If I want to retrieve the player stats, I have to use the stats. So I have to do something like player.stats to get the player stats, but if I want to get the enemy stats, I have to do enemy.stats. Right? Enemies.actual. Enemy.actual. So there is a disparity over here because it's the same kind of data that you're retrieving, but the variable is different. So what I'm doing here is I'm just adding a little new getter so that you can use either stats or actual to retrieve the player stats, and this will give us some level of parity. So now when I want to retrieve the player stats, you can just do player.actual. So then there is a similarity between how the player and enemy works, which is always a good thing. So here we just have multiple ways to retrieve the player stats. First, both the actual variable and the stats variable return us the same value. Yeah, so this is what I mean by just maintaining parity between the two scripts over here. Okay, this is not very important, but it's something that you might want to add. It doesn't change the way your code works, it just gives you more ways to use your own code. Once that is done, we will have to modify the game manager to track all the players. Okay, so if you look at the game manager script now, it only tracks a single player, and the single player that's tracked is right here. And what we want to do is just change things around. Firstly, we are tracking the player using game object, which is not the best way to do it, because if I want to get the player stats, I would have to get component and find the player stats, right? That's one thing. The other thing is that, well, if I have multiple players, then I have a problem as well, because how do I track all the players that I have? So to this end, we will make a couple of changes to the game manager script. Okay, we will remove the player object over here, and then we will replace this with a player stats array called players. This will allow us to store and track all players and store and track all players by the player stats variable, so it's a lot easier for us to retrieve their stats. So I'm just going to replace this, and of course this player stats object is private because you don't need to manage it, so it shouldn't be shown to the user. Second thing is that in the awake function, you want to of course just find objects, note the S here, find objects of type, just to retrieve all the players in the game. Players, find objects, so by finding all the players, what this allows me to do is to create a new function, and this new function is called getCumulativeCurves. Because every player has a curve stat, right? Does it make sense? So then we just want to have the total curve stat. And let me explain what's going on here, because this is gonna be pretty important. Okay, so over here what's going on is that we want to add all the curve stats of all the players together. But it's possible for the curve values, okay, if the total curve ends up being to be less than 1, because you know you can mess with the curve value in the player stats, right? So if the total curve value is less than 1, what we're gonna do is that we are setting a limit to the minimum value of the curves. So if 1 plus total curves, right, if this is negative, for example, if total curves here for some reason you manage to get it to be a value that is below 0, so let's say 1 plus minus 0.5, this will give us 0.5. So if this curve value is less than 0, right, it will cause problems because it actually weakens enemies, and we don't want the curve value to be less than 1. So here we are just doing a mathf.max and then 1 plus total curves. And what this does is that this prevents our curve value from falling below the value of 1. We're doing the same thing with the level, because we also want the level to not fall below a value of 1, because otherwise what this does is that because this is a multiplier, right, so this will cause some problems, because if the level, cumulative level is 0, right, and something times 0, this will give us value of 0, and then if you multiply this with any value, it will give you 0, which is not a problem that we want to run into, which is why we set these limitations. Okay, so what these two things do is they just add up all your curve stats or add up all your levels. And the reason I have this error here is because on the player stats I didn't add the actual variable over here. So this should be public character data dot stats, so then this should be get return stats. There we go. Okay, so now that we have all of this implemented, you will find that it's possible for you to retrieve the cumulative curve stats from the game manager. And we also have to, because we replaced the player object variable, right, we will also have to update our scripts. Okay, so in the game manager over here, besides adding these functions, we will have to remove this player object script over here. So because the player object is no longer there, we cannot run this piece of code anymore. Now what we have to do is we have to just loop through all the players. So this will be player stats p in players, and then we just do p send message, because we have to apply this to all, and this is the change that we have over here. Okay, instead of killing one player, you have to kill all the players when the time is up. Okay, so here we have one more part here that I have to change as well, because this refers to the player object as well. So same thing for each player stats, p players, p send message, apply and remove this. Oh, it's remove and apply upgrades. I'm sorry. So again, all of this is documented in the article, so you can just check out the script. So we're almost done here. So now that we have a way to retrieve all the curve values and all the level values, we have to tally the boosts. And this means that we have to go back to enemy stats and make some modifications to it again. Okay, so here let me just explain what's going on, right? Okay, so what I want to do here is I've implemented a multiplication operator. This allows us to multiply the resistance by a number. Okay, so for example, I can increase the freeze resistance from, let's say, 0.3 all the way to 0.6. And what I'm doing here is I'm just grabbing the freeze or the kill or whatever, and then I'm multiplying it by the number over here. And this will allow us to very easily multiply resistances, so that you can see over here I can just take the resistance and multiply it by a certain number. And this is only possible if I have the operator function above, right here. And what I'm doing here is, on top of just getting the value and increasing it by a factor, I'm also checking to make sure that the value is never more than 1. Alright, so if this freeze, let's say I have 60% freeze resistance and I'm boosting it 2 times, so this will be 60 times 2, right? This will give me 120% or 1.2. 1.2 is larger than 1, so then if this value becomes larger than 1, it will just set the value to 1, because it doesn't make sense for your resistance to be more than 100%, right? Because 100% means that you are just blocking the effect entirely, so there's no reason for you to have a resistance of more than 1. So then when I have this, what I'm also adding to the stat struct over here is a boostable enumeration. This is again, these are flags, and then I have 2 boostable here in curse boost and level boost. And then after that, this is basically a static function that it's a private static function. So what this is, to understand what's happening here, you have to understand the operators for multiplication. And for this is I'm using a different operator because we can't use multiplication for both. So then for curse, if I want to increase the stats for curse, I'll use times. If I want to increase the stats by using level boost, I will use this symbol over here. And no matter what symbol I use, okay, you will notice that I call the boost function over here, and the boost function just takes a stat and it multiplies it by a factor. See that? Multiplies it by a factor. Except for the knockback multiplier, because the knockback multiplier will be divided. Because for the knockback multiplier, it's the opposite direction, right? The lower the value, the better it is. Higher the value, the weaker it is. Okay, because higher the value means more knockback. Greater knockback is always advantageous to the player. Okay, so for knockback, because you want it to work in reverse, you will use division. And resistances, again, you multiply. And again, this is made possible only because over here, we have an operator that defines how the multiplication operator works with the resistance. Yeah, so this boostable over here, right, this basically is a flag. So let me just copy it and paste the code into my script and show you what I mean. Let me paste them into the enemy stats, and I'll show you how this pans out. All the errors here should be fixed now. So if I go to the enemy over here now, so on top of having all the stats that you can adjust, you will also find an additional setting over here. Okay, so in the stats itself, you will find not just resistances, but you will find the ability for you to modify what the curse stat boosts. So by default in Vampire Survivors, the curse stat will boost health and move speed, and then the level you can make it boost anything as well. So over here, if you see in Vampire Survivors, HP times level. Okay, this can be implemented if you go to the level boost over here and check health. This means that the enemy's health will grow together with your level, or if you want the move speed to grow together with your level or damage or whatever, you can set them accordingly as well. Okay, but I think that will make the game pretty wacky, because if you multiply the move speed by your level, everything is just gonna move very fast. Okay, so you can control what your level boosts and what your curse boosts. So the default values are the values that are in Vampire Survivors, but if you want curse to boost damage as well, you can just select damage here. And then whatever you set here will go into the curse boost or level boost here, and then this will control what stats the curse operator boosts or what stats the level operator boosts. Okay, so once all of this is done and you have a way to boost the stats, you want to go over to recalculate stats and make some modifications as well, and these are the modifications. Okay, so you want to grab the curse and you want to grab the level as well, and then you just grab the base stats of the character, multiply by the curse value, and then multiply by the level value, and then this will cause the actual stat boost. So once you have implemented these codes, you can jump into your game and you can just adjust the curse stat of the character, and you will find that as you change the curse stat, the enemies will get stronger. So let me give you an example, alright? I'm just gonna start the game. So again, enemies are normal, they are going slow, but then once I increase the curse stat, you will see they start to get really scary. So here, let me just grow the curse stat to 2.29. See that? You have the red bat here and it's flying a lot faster. It's because the curse stat is higher, and mobs are very fast as well. So if I increase the curse stat further, you will see the enemies will get even crazier. So the curse stat is a very interesting way for us to adjust difficulty of our game. And if you have level boosts as well, right? If I were to set the level boost to, let's say, health, and what happens then is that now the higher my level, the more health enemies will have. So this is great for if you want to create enemies that are tied to your health. It's probably for the late game, you know, if you play Vampire Survivors in the late game, you'll find enemies become really hard to kill, and this is because your level is really high. Okay, so now you have some very interesting modifiers to play around with to get your game and to get your enemies to become more dynamic. And we're almost done here. So now that we've gotten the curse boost and level boost to work, the last thing to do is to just test it out. Okay, so the article explains how all this works. You can get the stats and you can multiply the stats by 1.5, and this will boost our enemy stats by 1.5. If you get the stats and you do a up arrow here, this will boost everything by 1.5 as well, but it only works for stats that are marked to be boosted by level. So this multiplication and this arrow sign here, this only works together with the enemy setting. So you have to set the curse boost or level. So if you set it nothing, for example, right, then even if you try to multiply the stats by curse or by level boost, you will not get any boosts. So the operator here is important, right? The operator that you use will control which setting is boosted. So whether it's by curse or by level. So the final thing that I want to implement on the spawn manager as well for curse is that notice that the curse will also affect the spawn interval of enemies. So for this, we can actually go over to the spawn manager. And then let's add a checkbox here called boosted by curse. And if the spawn manager is boosted by the curse effect, then what we'll do is that we'll just modify the activate cooldown function. So previously the spawns are controlled by a spawn timer, so then whenever the spawn timer expires, we will just find a new spawn interval and then set it to the spawn timer. So instead of doing this, because we are doing this in multiple places, we will use these functions with activate cooldown function, which does the same thing. It does the same thing except that now we take into account the curse boost as well. So if the boosted by curse checkbox is checked, then we will get cumulative curse. Otherwise, we'll set the value of the curse boost to 1 because anything multiplied by 1 doesn't change the value. And then we'll grab the same spawn interval, but we'll divide it by the curse boost. We'll divide it by the curse boost because, well, it's the formula that you see over here, right? Spawn interval divided by the curse. And this will give us a decrease in the spawn interval, which means enemies will spawn fast. Just a slight modification to implement the formula, the curse formula, into the spawn manager as well. And we're almost done for this part. The last thing that you want to fix, right, is that if you look at enemies in our game, you will see that they don't sort themselves very well. You will see enemies that are supposed to be behind, they sometimes appear in front of each other instead. And to fix this, we can do a couple of things. Okay, what I'm gonna do here is I'm gonna create a new script called sortable. And this sortable only works when you have a sprite renderer. And what we're gonna do is we're gonna make this class abstract. Why we make this abstract is because we want to apply this retroactively to some of our classes instead of attaching this as a separate component. So what do I mean by that? So what I want to do is this sortable class, let me just create this sortable class inside our scripts folder. And let me explain how this sort class works as well. Okay, so this sortable class, you can enable it or disable it, and it's just gonna be in the start function and it will find a sprite renderer. And then there's just a late update function over here. And what this late update function over here does is that basically it checks how far down you are on the screen. So the lower you are on the screen, the lower your Y value is going to be, right? And the lower your Y value, the higher your sorting order is going to be. So you will see here, basically, the sortable applies to anything with a sprite renderer. Okay, so anything with a sprite renderer, you can attach a sortable component to it. And this sortable component will take your position Y, the negative position, because the lower you are, the higher your sort order is going to be. So it's taking the reverse of your Y position and then divided by minimum distance. What this does is that basically the minimum distance here will affect, so for example, if enemies are, one enemy is lower than another by more than 0.2 units, it's going to try sorting it. So enemies that are very close to each other, we are not going to try to sort them. But enemies that are far away from each other, further than 0.2 units away from each other, we will try and sort them. And then basically we sort them in late update, and then we are just basically updating their sort order on the sprite renderer. Okay, so by doing this, right, you will find that enemies will automatically sort themselves. Instead of having the enemies that are higher up overlapping, you will find that after we implement this code, the enemies that are lower down will always appear higher than the enemies that are higher. So then we made this class abstract because how I wanted this class to be applied is instead of attaching this component to our game objects, we are just going to find the scripts that we want to be affected by this component. So most of the time it's going to be the movement script. So I'm just going to replace mono behavior here with sortable, and then what this does is that this will apply all the codes that's sortable to enemy movement. And I also want to apply this to the player movement script as well, so the player also gets sorted according to how high up or how low down they are in the scene. So sortable, player movement is going to be sortable as well. And whatever that you make sortable, right, I'm going to make the pickup sortable as well, so that the pickups will also sort themselves. So let me just find the pickup script right here, and I will change the pickup script to be sortable as well. Okay, so once we have applied all of these changes, you will find that the pickups, the player character as well as the enemies will have a couple of extra properties over here. Player movement, you will find there is a sorting active, and then there is a minimum distance as well, right? Because now we are able to get the player to sort himself with the rest of the objects in the scene as well. Okay, so one thing you have to take note of is that if you, after you inherit the sortable class over here, because the sortable class has a start function, so then that means that under the player movement here, we will need to make this protected override. So same thing for the pickup script. If there is start function, we have to make this overrideable, and we have to apply the same logic as well, where this is no longer virtual, this is override. And we also want to add a base.start to all of them, base.start, and then finally here we also have a base. This is because again the sortable will use the start function to get the sprite renderer, so you have to make sure that the start function is added to all of them, the base.start. This is all again documented in the blog. Okay, you have to modify sortable on the existing scripts by adding the sortable class here, and then by changing the start function to have protected override. Enemy movement is the same thing, protected. This is no longer virtual, but this is override. And for the pickup script, same thing. This has to be protected override, and then you have to call base start. And all of them you have to call base.start as well, because the base.start function will activate the sortable script. So you might be wondering why didn't I just design the sortable as a component? And the reason for that is because if I design this as a component, it's going to be less efficient than if I design this as a part of a player movement script or part of the enemy movement script or the pickup. And the reason for that is because if you have multiple components, it generally tends to slow down how fast Unity runs. So I'm just offering a different way to implement your sortable script. So for those of you who don't like to use subclassing, let's say you want to keep your player movement as a mono behavior, that's 100% okay. Just go to sortable and then remove the abstract class, and then this will allow you to attach the sortable as a component to your game objects. I just prefer to integrate sortable into our existing classes so that we have one less component to manage and to work around. So if this is all I have for part 22 over here. So once you have implemented this, you will find that enemies that are in the scene, they will always sort themselves automatically according to how far away they are from, or how high up they are in the map. So now we have the flower wall, and you see that no matter where you go, right, the flower wall will always have the correct sorting. And this is because we've added the sortable too. So now you see they're very nicely overlapping one another in the correct way. And if you check them out, you will see the sorting layers are always done correctly. So in the sprite renderer, the order and layer, this guy is 0. But then if we select something else, this guy is 11. And we select something else, this guy is 25. This is because the higher up you are, the lower your sorting order is gonna be. See that? It's extremely important. Yeah, otherwise if the sorting order is wrong, then you will get situations where you will have one flower appearing over another. Yeah, and the sortable layer, what it does is that it just makes sure the sorting is always correct. Depending on where the enemy is, sorting layer is always different, so that enemies that are above will never overlap the enemy that is below. So I hope you've enjoyed this part. This is I'm done with part 22. As usual, thank you for your support, and yeah, I'm excited to create a buff and debuff system after this, so stay tuned for that.